There we go. Have fun.
Thank you very much.
Hello, good morning, everyone, and welcome to the second day of Dev Days Europe. With me is Andrew Holway. Hi, Andrew.
Hello, how you doing?
Hi. Andrew, you're working at Darwinist. Can you tell a little bit about what you do for a job?
So basically, I've been an infrastructure engineer, software engineer for about nearly 15 years. And over the past 3 or 4, I've become much more focused on delivering basically learning outcomes in technology. This is something that's pretty much ignored. So topics such as how do you do professional development for a software developer, for example? This is something that's kind of abandoned. Developers are expected to kind of learn by themselves, and if they're not able to learn by themselves, then they're basically useless. So these types of problems, this is the kind of area that I'm playing in. How do you design learning for technology? That's basically my game nowadays.
Yeah. And the session that you have in store for us today is all about telling us how to bridge the gap between the lesson technical stuff and the technical stuff and all the learning involved, right?
So something like that. I mean, it's mainly going to be based around a specific case study and where we've taken a organization in the US in the space of a week, managed to turn around their entire cloud strategy. How we got them enabled, what technology and organizational choices we had to make in order so that could happen very, very rapidly. And so just this talk is very, very opinionated, but you've got to remember this is in the context of, hey, this is how you do it if you want to do it in a week, basically. If you've got a bunch of people over here and they have to do this very, very quickly. So this talk is about how to simplify, basically it's about simplifying to an extreme degree, finding a very, very simple pattern that can be picked up very quickly by people who have no idea what they're doing with this new technology.
Yeah, very good. Well, let's dive right into it then. I'm sure everybody's curious to find out what you have to tell. After 40 minutes, we'll be back with Q&A. Do feel free to put all your questions in the chat, and have fun, Andrew.
Okay, I'm going to try and share my screen here. Let's see if that works. So is that working okay?
Yes, we have visual, so you're good to go. Have fun.
Excellent. So I'm Andrew, and this is my company, Darwinist. We're based in Estonia, and I mean, very, very generally, can I ask? Can people see my mouse? Do I have a pointer or not?
Yes, we see your pointer and your context menu.
I have a laser pointer. That's fantastic. So basically, we're into helping technology teams, helping business teams to retool. Okay, so hey, we want to do Kubernetes. Hey, we want to do Elasticsearch. Hey, we want to convert our analysts to do Python pandas, for example. We're really about helping businesses retool. We're about helping businesses to invest in their people. And I mean, it's not just a clever name. We're really here to help businesses evolve from a technology perspective. This is me. I used to build supercomputers for various scientific projects. I'm primarily a deep infrastructure specialist, so networking and storage, but also I've been doing software development for quite some time. I am a rather mediocre developer. I don't think I'll never be a rock star developer. I have failed as a CTO, but I've been working in technical consultancy for many years, and now, for the past 4 years, I've been deeply obsessed with instructional design, and we'll talk about what that is. So, instructional design is basically designing and delivering a learning outcome, very, very basically. You find instructional designers in universities. They'll be working with professors, ensuring that those professors are really able to deliver a specific learning outcome to the students. So I design learning, and I design learning within a consultancy scope. So everything we do at Darwinist is delivered as a learning objective. So we're basically technology consultants, but everything that we do is a designed learning objective. That means that when we work with our clients, there has to be a group of people, say this group of developers must learn this thing so that the business can do this other thing. We're basically capability builders. So most technology teams are very, very good at developing within their known sphere. Okay, so we've chosen our web framework, we've chosen our front end, we've chosen our database, we understand those technologies, we understand those capabilities, and we're able to make new features based around that technology. But most teams really suck at adopting new technologies, because adopting new technologies is really difficult. Adopting new technologies is not their core business. It's not something that they're doing every week. Agile software development, Scrum, for example, it only really works when you've made your core technology choices and you're wanting to create features. Really, when you're looking for technologies to use, when you're trying to maybe switch from this technology to that technology, that's something that Agile does not handle very well, and people are often scratching around in the dark. So people try and handle this in various ways. They will do research spikes, for example. They'll have a single engineer will be working within a time box to try and research something. They'll be trying to put together maybe some kind of basic POC. But this type of approach puts a really difficult burden on this specific engineer and also the rest of the team. You basically have one team member that maybe kind of knows something. It's very, very difficult for them to reliably advocate for a solution that they've put together for the rest of their team, because the risks are kind of high. What if it doesn't really work out? Do I really want that kind of responsibility? And as well, that developer is just confronted by so much noise. If you look at technologies like Kubernetes, for example, there's a million different ways that there's a myriad of ways that you can implement Kubernetes, that you can implement Elasticsearch or whichever technology. There's no solid, it's very, very difficult to find solid patterns. So introducing a technology really is discovery of a simple, effective pattern. But it's so noisy on the internet, it's very, very difficult to find those patterns. It's very, very difficult to find a nice, clean example that you can follow that fits within your specific environment. So I'm going to introduce our main product, which is Skill Sprints. And I'm doing this I'm doing it a little bit to plug Skill Sprints, but I'm also doing it to provide context of how we work and why this talk probably seems very, very opinionated. So basically what we do is 1 week, very, very intense enablement and upskilling sessions. Basically, we turn up, we take 2 or 3 of the client's engineers, and we basically work with them to build something real within that space. That could be a new CI/CD pipelines based on Kubernetes. It could be a case of refactoring their entire Elasticsearch. It could be about getting them onto Amazon Web Services. It could be about switching them from PHP to Golang, for example. So one of the things that we did before was switch monolithic PHP developers into Golang microservices developers. And it's very, very important that the output is going to be delivered by our customers' employees. We're hands-off. I mean, we do a lot of testing before everything's designed, so we do a lot of testing. We know what will be delivered, but when we arrive and when we work with our customers, we are strictly hands-off. Things have to be delivered by our customers' employees to prove that capability has been built, basically. So this is just the context of this talk. We have skill sprints which are very, very intense, 1 week on site. This is when a customer knows what they want. They're like, yes, we want Kubernetes and we needed it yesterday. And then there's capability cultivation. This is a much slower, 1 year, remote, low intensity. This is like, oh, well, we're kind of getting into this technology and we need some guidance and support, basically. So, training. So within technology education, training I don't think it has a great name. Everybody's probably done some level of technology training, but for technology, it's very, very difficult. the first thing is up here, you can see what's called the forgetting curve. The forgetting curve basically makes acquisition of knowledge very, very difficult. So you can see here, on day 0, you've learned something, and you can see that the fall off of the retention of knowledge, after 3 days, you're only maintaining 60% of what you've learned, and this continues down here. But you could combat this by having regular reviews, basically. So you can see in every time you review, the knowledge fall off gets less and less and less and less. And after 5 reviews or so, that you can say that you really have that piece of knowledge. But it's very, very difficult. And unless you have regular reviews, so if you're doing training, for example, and unless your students are very structured, or unless you force it to happen, reviews are very, very unlikely to happen. And they're very, very unlikely to happen within this type of schedule, for example. So somebody may go on a course for a couple of days, then they go back to their job, then they're very, very busy for a few days because they've got to catch up. And then maybe after a week, they're starting to review the contents of what they learned, and they're going to find that they've nearly forgotten everything. Also, understanding the difference between explicit knowledge and tacit knowledge is very, very important. With technology, and so when I talk about technology, I'm talking about computer stuff, I'm talking about carpentry, welding, mechanicking, construction, use of technology. The vast majority of this knowledge is what's called tacit knowledge. Tacit knowledge is knowledge which is very, very difficult to transfer from one person to another person. It's knowledge which we have to learn experientially. We have to do the thing. We have to feel the tools in our hands, and we also have to have an emotional connection to this work and to the tools. People seem to think that technology is a very, very explicit knowledge thing, that by having good documentation, I mean, good documentation is always a nice thing to have, but really it's only 5%. The rest of it, the vast majority of everything involving technology is just this experience that we have. It's so contextual, and training doesn't really provide the right context for, doesn't really provide an appropriate context for learning new technology. You can also see this by all of these online courses from Udemy or Coursera. I mean, it's very, very difficult to learn something useful from these courses. It's very, very difficult to take something from these types of platforms which can be taken back into your job. Consultants. So I'm going to be a little bit careful because I'm also a consultant. But one of the problems that we face with consultants is that basically you have an external organization, you give that external organization or external person a parcel of work, they complete it, deliver it back. The thing is that you're then reliant, because of the nature of the knowledge, because it's tacit knowledge, because it's experiential, it's very, very difficult for your employees to then really adopt what that consultant, what that freelancer has done. And so you end up, I mean, probably everybody here has probably experienced this, where something's been outsourced, it's come back in, and then the permanent developers are like, yeah, well, we didn't do this, we don't know what this is, better go and call the consultant again if you want anything done on this. It's very, very difficult to take this external work and then have it adopted by a internal team. So I'm going to jump into a case study now. So basically DMSI, they're based in Omaha, Nebraska. They've been running since the mid-70s. They're in a fairly traditional space, building ERP for the construction industry. And they've been trying to get Kubernetes under control. They have it under control now, but they've been trying to get it under control for more than 2 years. They're still in the throes of doing this. They're basically in the middle of doing a massive technology refresh. They're using some quite interesting old technology from the mid-90s. And they're wanting to basically get into Golang microservices. They want to get into modern front ends. And so they really needed a place to deploy all of this stuff, and they'd already targeted Kubernetes. But again, they were unable to find a good pattern. They weren't able to properly test things. They didn't have proper dev and test environments. And as they say right here, they were inundated with blogs and tutorials. And this is a big problem. I mean, the internet's an amazing thing, but there's a million different ways that people are proposing that you do things. And unless you have a lot of dedicated time, it's very, very difficult to filter good stuff from the general noise. So The first step in what we did for them was to define an appropriate technical and organizational schema. So not a schema, sorry, rather a technical and organizational, let's say a schema. That's a good way of putting it. So basically, you have over here, you have something that we can call a platform team. Some people might call this a DevOps team. And then over here, we have some developers. And these developers are obviously developing applications which are consumed by customers. So basically, the first step here is to make sure that we want to make sure that we've got Kubernetes clusters. We want to make sure that we've got database instances. And the platform team or the DevOps team are generally responsible for deploying Kubernetes clusters and database instances. However, that's where their responsibility ends, is with the deploying of clusters and the deploying of instances, because the development team are going to be responsible for schema. They're going to be responsible for schema within the database. I mean, I don't know the last time that I saw a DBA, but now, so development teams are generally responsible for database schema, and they're also responsible for schema of the application within Kubernetes. So when we talk about microservices, one of the things that we have to think about is what's the schema of our application. And when I say schema, you could say what's the topology of our application. And we'll talk a little bit more about what that means later. But basically, what this means is that you have a fairly neat line. It means that the dev team are going to be generally responsible for kubectl. So if you don't know, kubectl is the client, is the command line client for Kubernetes. And the platform team are going to generally using Amazon Web Services CLI, maybe Terraform, or they're going to be using the Google CLI or Terraform for deploying instances and deploying Kubernetes clusters. So the dev team do consumption and the platform team do provision, basically. So complexity. So this is something that I think is very, very important that everybody understands, which is the amount of complexity that we can reasonably manage within specific infrastructures. So when we go back 10 years, 15 years, we had on-premise monoliths. So we'd maybe have like a big PHP application. This could have been deployed onto a bunch of servers, which with some kind of hardware load balancer, or maybe HA proxy or something like that. And generally with this type of infrastructure, we can manage a complexity of X. As Amazon Web Services started to become dominant, it was very, very clear. I mean, with Amazon Web Services, we had auto-scaling groups, we had load balancers, which could be deployed very, very easily. We had all kinds of interesting tricks. Amazon Web Services had all kinds of interesting tricks. And this basically enabled us to have a infrastructure complexity of X squared. With auto-scaling and load balancers, we had S3, which is completely amazing as a storage. There's no S3, or it's very difficult, or it was very difficult to do S3 style storage on premise. Amazon Web Services provides so much good tooling, we can now handle a complexity of X squared. However, you can't do microservices in raw AWS. I mean, you can try, but you're gonna have a bad time. So Kubernetes basically enables us now to have an application topology complexity of X cubed. So with Kubernetes, we can basically have application topologies that are 100 times more complex than on-premise. I mean, you can now put Kubernetes on-premise, of course, but you get the idea. So Kubernetes basically enables us to have much more complicated application topologies. We can do really, really interesting stuff with microservices. We can have auto-scaling to the wazoo. It's really powering modern complex architectures. So I think I've got my slides slightly mixed up. I think yes. So let's talk a little bit about the reasons why this is. And most people may be familiar with the concept of imperative versus declarative programming, but we are now in a world of imperative versus declarative infrastructure. So with Amazon Web Services, basically this is an imperative platform. If you want to do things in Amazon Web Services, you've got basically an order that you have to do things. you have to create a VPC, then you have to create some subnets, then you can deploy an instance, then you have to configure the instance. You've got specific discrete steps that have to be completed in order for things to work. And you have to understand these steps, you have to understand the dependencies of these steps. Amazon Web Services is an imperative platform, which is not great. Kubernetes is a declarative platform. You provide Kubernetes with a schema, you provide it with basically a bunch of YAML, basically an object. You throw the object to Kubernetes, it works out how to get to that state, basically. You don't have, I mean, there are a couple of small instances where there is an imperativeness, but for the vast majority of everything, Kubernetes is a declarative platform, and that's very, very good. So AWS is instruction-driven, and Kubernetes is schema-driven. And so this means basically, I mean, if you can handle X cubed complexity in Kubernetes, that means that complexity becomes much cheaper in Kubernetes. Complexity in Kubernetes is cheap. It's easy to manage complexity in Kubernetes. It's relatively difficult to manage complexity in Amazon Web Services, and it's horrible managing complexity in on-premise monolith environments. So that leads us to the conclusion that in order to have efficient infrastructure, we need to radically reduce our Amazon Web Services footprint. We do not want to put stuff in the cloud, or rather, we do not want to use cloud proprietary services for our infrastructure. We really, really want to keep things in this happy Kubernetes declarative land, where this complexity is easy to manage. So, talking about tooling, for example, I am not a fan of Terraform, and I'm not a fan of Helm. So Helm and Terraform are basically abstraction layers. Helm is an abstraction layer for Kubernetes. It's basically a templating or abstraction layer for Kubernetes, and Terraform is an abstraction layer for Amazon Web Services. And I've never really seen the benefit of these toolings. It's a difficult thing. I'm still digging into this a lot, but I think generally this sort of mania about infrastructure as code is a little bit over the top. And it's especially over the top now that we've got Kubernetes. Infrastructure as code is kind of redundant now, if you look at it carefully. So we're now in a world, now that we're getting to a point where we're radically reducing our Amazon Web Services footprint, what complexity we have left in Amazon, we can easily handle using CLI commands, for example. We need to deploy a database, we need to deploy a Kubernetes cluster. You don't really need third-party tooling for handling that level of complexity. And of course, kubectl is the standard tooling for Kubernetes. Unless you're distributing software, unless you're wrapping up and distributing software and sending it somewhere else, maybe you've got an on-premise customer, or maybe you're distributing your software to other companies. Let me say that again. If you're only running software within your own infrastructure, you do not need Helm. If you're packaging up a cloud native application and sending it somewhere else, then Helm becomes something that you could use, maybe. So Terraform is basically trying to make Amazon Web Services declarative, essentially. And I don't think it does a very good job, personally. Some people are very, very keen on Terraform. They really, really love Terraform. I'm really, really not keen on it as a platform. It makes life very, very difficult. It's very, very difficult to teach. It abstracts away. And again, now that we're in a world where we're going to be reducing our Amazon Web Services footprint, I think it's less and less relevant with each day. So this is just an example of what you can do with Kubernetes. I'm afraid I put together this example last night. It's probably not the most, probably not, oh look, I've even left my mouses in these screenshots. So basically this is a service. So a service is a type of object that sits inside Kubernetes. It does load balancing and service discovery. So basically a service is something that we put on top of a bunch of containers, basically to make those containers discoverable. And so this is a very, very simple thing that you can do. Envsubst is an amazing tool that enables you to template. So for example, here we've got some environment. We've set some environment variables in our CI/CD pipeline. And basically what we can do here is basically template in these values using envsubst. And then we can pipe that output directly into kubectl. So we can basically take a bunch of YAML, we can template it with envsubst, and then pipe it directly into kubectl. There's also other ways of doing this. This is basically my suggested alternative to Helm. But there are other ways of doing templating. But this is by far the most simple. Envsubst is just available in most CI/CD environments. It's easy to install. It's available in all Linux distributions. It's easy to get into a Docker container. It's there and it's easy to use. So if you're putting together a CI/CD pipeline for Kubernetes, I'd strongly suggest trying it out using this type of schema, or trying it out using this type of system, rather than trying to do something more complicated with, for example, something more complicated with Helm, for example. So yeah, for me, envsubst is life for me. I use it a lot. So you can have a look, if you have a look in GitHub, here's my, you can have a look at this. It's not incredibly well done, but you can have a look example and see how it works. I'll just leave this for a moment so you can take a note. I think we might be able to put that in the chat as well. So this is a slightly contentious issue that I will tread carefully. DevOps is a really, really tricky thing to get into. I'm a little unsure. I mean, DevOps originally started as a way of saying, okay, so developers can start doing their own operations. They can start doing their own deployments. System administration is something that can be handled by developers. We can provide tooling to make that easier. And let's try and sort of get rid of this layer of system administration. But what's happened in reality is that system administrators have been basically replaced by DevOps consultants or DevOps engineers, however you want to. I mean, this is a kind of job that I did for a long time. But we went from system administration to DevOps engineer, and now we've gone to SRE, and they're basically the same thing. There's a joke that's often said is that system administrators do it with Perl, DevOps engineers do it with Python, and SREs do it with Golang, but it's the same kind of. There's some distinction. I mean, SRE is another thing altogether, but I think DevOps engineering is basically system administration on Amazon Web Services. And I think you could argue that this is something that is promoted by Amazon Web Services. If I was in a dark mood, I would suggest that DevOps engineering or DevOps engineers is something that's promoted by Amazon because it enables them to have an embedded layer of staff within organizations. SAP follows a similar kind of structure where they basically, you can't use SAP without having SAP consultants. If you want to use SAP software, you have to have a bunch of SAP consultants. If you want to use Amazon Web Services, you have to have a bunch of DevOps engineers. And this can mean that you end up with very, very bloated, weird, very expensive infrastructures on Amazon Web Services. And these DevOps engineers may have a vested interest in ensuring that Amazon Web Services has a dominant position within their employer, because if it doesn't, then their value starts to wane. It's a very, very difficult thing. And you just need to be aware or beware. That's a difficult thing. If you're doing DevOps and it's taking longer than a month, something's wrong. Basically, if you're in a situation where you're having a team of DevOps engineers and they're working for months and months and months and things are still not really resolved, something's really wrong. And you need to really, really reconsider the role of that team and what's their mission, because it just isn't that hard anymore. So this is the core message: keep it simple, stupid. This is often forgotten in the world of infrastructure, but it's really, really important. So basically, this was the output the DMSI case study. So in the space of 5 days, we managed to get them out of the mud and managed to get them on their way. And now they're completely independent. What's really, really nice is now that they've been given a pattern, their DevOps practice or their CI/CD practice is incredibly good. It's actually better. They've taken what we did with them and they've really run with it. And now they're doing incredible stuff. They just needed a push. They just needed to get moving. And now they've taken it and run. In fact, they're doing stuff now that I would struggle to keep up with, I would say. Going to talk a little bit about cloud platforms and what it means. And so I'm talking here about AWS and Google Cloud and the differences. Remember, I'm coming from a perspective of learning design. I'm talking about how I'm concerned about how quickly can this group of engineers, this group of software developers, how quickly can they adopt this technology? So Google Cloud Platform is by far the easiest to adopt. It just works. You can deploy a Kubernetes cluster, you can deploy a database instance in very, very quickly. You don't have to think about it. You don't need any third-party tooling. In fact, you don't even need to use a CLI. The options that it gives you just by clicking in the Google Cloud GUI, it just works, and you don't have to think about it. I believe that with Google Cloud Platform, concepts like infrastructure as code basically become completely redundant. You don't really need to think about it like that anymore. Google Cloud Platform is also very, very good for software development teams because it has this amazing project-based, this sort of project-based way of dividing up resources. So you can provide a project to your software development team and they can consume Google Cloud via their project directly. It's very, very easy to set up. Amazon Web Services, as we've talked about before, as we've just talked about, is a lot more difficult to get to grips with. Amazon Web Services and Google Cloud are both very reliable platforms, but Google Cloud Platform is definitely better designed from a user perspective. Amazon Web Services is, in my opinion, quite poorly integrated. I think this is because Amazon Web Services follows this sort of internal competitive model where they have disparate teams that are kind of in competition with each other. So in Amazon Web Services, for example, you have, I don't even know, 2 or 3, maybe even 4 containerization platforms running now. There's Fargate and there's Elastic Container Service, there's Elastic Kubernetes Service, and they're all competing with each other internally for the same market. Because Amazon Web Services tends to be quite poorly integrated, you tend to rely on third-party tooling like Terraform, which I think is a bit ridiculous. Why do I need third-party tooling for deploying things on Amazon Web Services? The Amazon Web Services Kubernetes experience is, I mean, it works once you get it deployed, but still you need third-party tooling to do it. And you need a tool called, the best way of doing Kubernetes on Amazon Web Services is using a tool called EKSCTL, which is developed by Weaveworks. And it's third party, and I don't really understand why that's a thing. It's quite complicated and difficult to get your head around to begin with. Kubernetes is quite difficult to get your head around to begin with. Amazon Web Services don't really try and make it any easier. So if you're a software development team and you just want to get up and running and you want to deploy some applications, you want to use some databases, Google Cloud Platform is very, very much the way to go. And I'm not by no way affiliated with Google. Amazon, if you're using Amazon, there's probably a political reason why. Either they're giving your organization deep discounts, or maybe you've already got this layer of DevOps engineers in-house which are keeping this thing there. Amazon Web Services does have more features than Google Cloud. It does have a wide repertoire of services, but it depends on what you're doing. Look carefully at the reasons why you're using Amazon Web Services. Microsoft Azure, I mean, I don't know what to say about Microsoft Azure. 3 raccoons in a trench coat, posing as a cloud provider. I stay away from it personally. It's unreliable, difficult to use. I think Azure's main market is Microsoft shops, are companies that are very, very heavily invested in the Microsoft ecosystem. I think that's where it makes sense. But using using Azure rather, is very, very labor intense. You need to have quite a lot of people running around poking things, and things fall over. You have to stand them back up again. It's difficult to consume. The interface is often inconsistent. It's difficult. Stay away. Is my advice. So just talking a little bit, just to clear up basically our modus operandi, so how we're working. So at our core, we are basically technical consulting engineers, but everything that we do is delivered in the form of educational outcomes. And it's important to remember that everything that I've just been talking about for the past, 25 minutes, is really about, we've had to make these specific choices because we have to get our customers set up very, very fast. We prefer Google Cloud because it's fast. We prefer Kubernetes because it's fast. We prefer to avoid Terraform and Helm because it's fast. And that's what we're really concerned about, is how quickly can we get these people skilled up, clued up, and working with a new technology. So we generally do, so when we work with a client, we're generally working directly with their employees, and we teach employees on the job. We are basically helping our clients to invest in their employees. We're delivering continuing professional development for these employees. And this approach enables our clients to be independent from us. We do not want unhealthy dependence. We're not looking for extensions. We work on fixed price only. We're not interested in time and materials type opportunities. And yeah, so basically we enable our customers to invest directly into their employees, and we are helping our customers to build new capabilities. So these are the technologies that we work with. Obviously, there's Kubernetes, there's Git, there's MS SQL, Python, Golang, Google Cloud, obviously, Elasticsearch. We do a lot of DevOps type stuff. Postgres, MySQL. I've still got Azure here. I should probably take that off. We have touched Azure. It was difficult, but we touched it. One of the most interesting things that we did recently was take a team of PHP developers and in the space of a week turn them into a team of Golang microservices developers. That was pretty nice. So our customers are generally customers that are wanting to work with external support when trying to get to grips with a new technology. We also work with technology vendors that want to get their products into the market faster and deeper. These are the type of areas where we're playing. And that's me finished. So I guess I'm handing back over for questions.
Yes. Thanks very much, Andrew, for this nice session. We have 2 questions by Christian Skronis, and I'll just read them out so you can answer them if you will. How do you go from everything is on fire, we need to ship in 2 weeks, there are bugs and our backlog is growing, to, oh, hey, let's set aside X days or weeks to learn about why, despite what sales, business, and clients might say? Do you have any skill sprints?
So I have yet to successfully sell a skill sprint to any business that's on fire.
Please elaborate.
Well, when businesses are on fire, they're very, very, very. When businesses are on fire, or when technical departments are on fire, if there's bugs everywhere, the last thing that those businesses are willing to think about is doing new things. Like that's just not going to happen. We have. I mean, right now I'm talking to a large organization in Germany, and they are very much on fire. They're a very, very large organization, and they're very, very much on fire. And because of COVID, for example, and because of what's going on in the market right now, there's a lot of people leaving. They're also trapped in a very, very weird Amazon Web Services situation, and they can't really get out of it. But when I'm trying to talk to them about, hey, well, we could try doing X, Y, Z to get you on the path, they don't have the headspace. They just do not have the headspace. So in answering your question, I still haven't managed to get through to a customer that is in that position. It's very, very difficult. If the leadership doesn't have the headspace to find, once you're in firefighting mode, everything is lost. It's really, really difficult. Sometimes, I mean, the types of customers, I mean, DMSI, for example, they're a very graceful organization. Things are going they're growing and things are going very well. They're trying to do new things with technology, but there's no panic because there's no panic for them because they're happily selling their existing product. Money's coming in. The organization is stable, and they're like, but their new software development team that's basically their software development team that's doing all the new stuff. They are delivering a small amount of value to the customers, but they're not the main show yet. They will be in a year, but right now they're not the main show. And so there it was quite easy to sell that in because they were like, well, we're trying to get from A to B. We're not on fire, but we're just frustrated because we've been stuck on this for 2 years and it's driving us insane. But it wasn't on fire per se, but when things are on fire, that could mean that the business is failing. It could mean that the management is failing. It could mean that the technology has so much technical debt that it's really hard. Like the organization's just gone past the point where they can pay that back.
Yeah. And, so if we would take out the part of the firefighting, I think there's still a valid point in the question: how do you justify investing a full week, taking people for a week out of doing the usual things, and how do you sell that to your organization or your management?
So it's that's a really good question. I'm still working that out. But it's the sales thing is really interesting. I mean, there's got to be some pain. There's got to be some suffering involved. That's the main thing. So if as a technical department, for example, your CI/CD is a mess, your cloud bills are massive. So what a previous customer, they had insane cloud bills. They were spending just on this was a small organization. They only had 3 developers, and they were spending $2,500 a month on Amazon Web Services just for their staging, right? That was an immediate piece of pain. It was like, well, if we do this, if we re-engineer this immediately, that $2,500 is going to go down to less than $100 or $200. So that was an easy point. Yeah, that's really interesting. I think if the management doesn't immediately see the benefit of it, if they're not like really aware of how that could be of a benefit, then I think it's difficult to sell. The customers that we work with are generally customers that really understand that an investment in their staff is really an investment in the business, right? So you have it's really weird when we're getting new customers. It closes within 2 or 3 days. We get from the initial interest to closing, it's a couple of days, and that's always management that's like, yes, we've been trying to work out how to do this for the past 5 years. Yes, let's do it, because they've been looking for ways to invest in their staff. They know, for example, this type of management, this type of leadership understands that investing in technical staff is a really good way of keeping technical staff around for the first thing. Like if you are a business that's really focused on investing in staff, those staff will not leave you. They will stay. The only reason why developers are on this like new job carousel is because they need new experience. And that new experience, those new skills are just not available within their jobs. Adopting new technologies and getting to grips with new technologies is incredibly risky. Like incredibly so, because nobody knows how to do it. If you're trying to do it yourself, it's 6 months of what the hell are we doing, and this doesn't work, and these cloud bills are really big, and we turned on CloudWatch, and now suddenly we've got a €10,000 bill. It's feeling your way around, especially when you're in pay-as-you-earn, especially within cloud environments, where suddenly if you turn something on, then suddenly you're getting an extra €1,000, €2,000 of cloud bills. It's really risky, and the outcomes are really uncertain. So management.
Can I just interrupt you for a second, because we're 1 minute away for the end of the session. There are 2 more questions by Christians that you might want to look into. I'm not sure if we can answer them now, but he wrote them in the section for Q&A. So it would be good if you would find some time to answer those as well. Yeah. I think we'll manage that in the 30 seconds that we have left. But I do want to thank you in the remaining time for delivering us this session and giving us a new take on how we can invest in people and upgrade their skills by this short week period. Thanks very much, and thanks, audience.
Thank you, audience.
I hope to see you after the break. There's a panel discussion going on. Panel discussion on serverless and service mesh. What is next? Hope to see you there. And then in the afternoon about event sourcing, what could possibly go wrong. Thanks, Andrew.
Thank you very much.
Everyone.
Take care. Bye-bye.